Hi, folks. Welcome to the webinar. My name is Dan Mallinger from Think Big Analytics. And I'm joined today with Will Rumpala from Kantar Media. And
Hello, everyone.
So, Will, can you advance the slide one? Experiencing a little technical difficulty on my side. Thank you.
No problem.
So as I mentioned, folks, I'm representing Think Big Analytics. So we're a pure play services firm in the big data space. We've been labeled as one of the fastest growing big data startups. We're headquartered in Mountain View. We have offices and additional offices in Salt Lake City, Chicago, Boston, an additional presence in New York City and Austin, Texas. Our firm is really focused on three main priorities: technology, working with folks to really achieve success with velocity and big data; data science, really working with teams to extract value and insight out of data sets through big analytics; and then finally, we have an education wing of the firm that helps firms really understand what they can do with big data, get their skills up to date, transition the skills they have today into those that are necessary to really be successful with big data. So the title of this webinar is Digital Marketing in the Cloud. And we're going to walk through a big data use case of collecting and creating value from video ad beacon data. Throughout this webinar, if you have any questions at all, please just type them in, and we'll have a Q&A session at the end of the webinar. So with that, I'm going to hand things over to Will, who's going to tell us a little more about the use case and how Kantar Media came to realize they needed a big data solution for video ad data. Will?
Great. Thanks a lot, Dan. Good afternoon, everybody. Just a quick section about me and why I'm here. I'm actually just a customer, but I'm actually with Kantar Media. I'm the Vice President of Production Systems, and the area of responsibility for Kantar Media is in data collection of advertising activity. My actual responsibility area revolves around the internet, both online advertising, online video advertising, as well as traditional print, magazine, newspapers, and billboards, etc. Just to give you a little bit of perspective who we are, I have a couple things in here about us. Kantar Media, we're actually part of WPP, the world's largest holding company. So really, we're part of a family that is all about advertising agencies primarily, but we're on the intelligence side. We monitor pretty much everything that happens everywhere, of course, so we know everything about what's going on out there. At least we try to. We do actually have the largest advertising database in the world. We do. Under the Kantar Media umbrella, we do act in more than 20 countries. We monitor pretty much all activity that we can find out there across 26 different media. When we talk about North America, where we fit in one of the family of companies that do advertising intelligence. Our sister companies that we work with and we share our data with, though, are we have things that are verticals for healthcare, political advertising, coupon redemption, audience measurement, and things like that. So just want to give you some perspective on that, so you can understand where we're coming from on this particular use case. We have, as part of our monitoring that we do on the online activity, one of the areas, of course, is video for online video advertising. Now, the way we currently do that is we have a very large. We take a sampling approach, a statistically significant sample of advertising activity by using a video spider proprietary technology that we developed ourselves, that goes out and truly behaves as a consumer, and tags the online video advertising exposure that it receives. Now, in the case that we had, we were working with one of the largest video online portals, and it turns out that we wanted to make sure that we were monitoring the activity on their site, and it's important. It's important for them because from a publisher standpoint, they want to make sure that their advertising activity is seen by us because we're the metric that people use to determine where they should place their advertising. We can be a third party, a disinterested third party that you can use as a metric or a currency to say this is what's happening on that site. Maybe you should be there as well. That's the idea. So this partner certainly wanted us to be able to measure their activity. However, unfortunately, they are pretty much a walled garden when it comes to outside looking in. Every piece of activity that's occurring on that website between the server and the client browser is encrypted, because obviously they're very protective of the content that they actually show, but even the advertising activity was encrypted at that point. So we entered into some conversations because they wanted to make sure that we could see their data. That turned out to be really, we went through a bunch of different conversations on there. We were discussing, batch transfer of data, large volumes, trying to get those files back and forth, and that none of those other options really made any sense. There was a methodology. How could we possibly do a sample by pulling data from them as a sampling methodology? The most logical answer there, of course, though, was truly doing a direct measurement relationship. Now, direct measurement is truly using beacon technology to receive a notification of every single ad play of every single visitor to that major site. We would receive a ping with some indicative data, no PII or no personally identifiable information, but we would know that a certain advertisement was played at a certain date and time. Now, with direct measurement, of course, comes certain challenges, and infrastructure is the first thing that comes to mind. We're talking about truly millions and millions and millions of transactions, between 45 to 55 million transactions every day. And of course, they're not all nice and smooth, of course, too. So you have ebb and flow throughout the day. We're talking, thousands of transactions per second, depending on time of day. We needed to make sure that we were truly real time. There was not going to be any sort of impact on the consumer. We wanted to make sure that we could handle not only just receiving all that data, but also storing it, calculating it. How do we sum and create aggregations on different dimensions that were important to us? And of course, the big fear that you have is, what is this going to cost? I mean, as a customer, it's how do I invest in this to make sure that I can handle this type of the capacity, and what's it going to take for me to, what do I have to build out, and not for today, but also looking forward. So it was pretty clear, within a few moments of looking at this as a solution, that the cloud approach was really the only reasonable solution here. So with us, we knew that we needed an elastic solution, right? So we needed something that could handle our scaled today, but also could scale if there was some sort of additional traffic that grows over time. We also knew we needed to be able to compute. It was not just the capture as one of the big things that Dan is going to cover in a bit. It's not just the capturing of the volume of data, but also how do you handle that data, manipulate it, and compute and extract the kind of meaningful business intelligence that you need out of it. And that's what really was pretty clear that we needed this solution. Now, I did a bunch of different research with a bunch of different partners, and I'm sure if you're listening to this, you probably heard this already, but Amazon, there's no comparison out there when you're looking at the capabilities of cloud providers for compute on demand. They're years ahead of anybody else out there, so that was a pretty easy answer. I approached Amazon with looking at this project as how could I get something up and running that was going to get me meeting what I needed to do right away, but at the same time provide something that I could grow with. This is our first foray into direct measurement and I wanted to make sure that it wasn't going to be a single project that was just going to be okay, well, that works, but now how do I adopt that into my internal operations, and et cetera. They pointed me to ThinkBig as a local partner that could help us with this, and we created what was, I think we called it a proof of concept Kickstarter or something like that, where it was a short-term engagement where at the end of the engagement, not only were we going to get an architecture, but they were going to help us assist build it out with my own resources, so that it was really a partnership, not just a contractor, hey, go build this for me and let me know when it's done, and then I can hope I can read the manual. It truly was a collaboration. So we kicked it off, and really in a very short period of time, we had a functional platform. Dan, you want to go over how we went through and determined the requirements and actually the analysis?
Absolutely. Thank you, Will. So at the time Kantar came to us, so at the time Kantar engaged ThinkBig Analytics, they had an opportunity to work with a major video site, as Will kind of outlined, but there weren't any hard specifications. Really what we had were some key overall requirements that drove forth the need to uncover the best architecture for for the problem they were solving and the state of their organization. We'll talk a little bit more about how those two interplay in a little bit. But so overall, these big requirements are, one is scale, right? Now, that's a problem everyone hears in the world of the web, in the world of big data. So we have, distributed events from clients who are, visiting this video site all over. You might be getting, I think the peak rate is around 1,200 events a second. And throughout that, you need a lightning fast response time. So in the online advertising space, you really have to have a response time that's under 200 milliseconds. And that's an industry benchmark that's critical for a number of reasons. The biggest one is that in the web world, every millisecond that an ad is taking to respond is a millisecond, or an ad tracking beacon is taking to respond is a millisecond that disrupts the user's experience on the site. And so fundamentally, it's a key aspect of user experience. The other side of it's really an internal industry metric. So you'll see firms that check each other out in terms of what are their response time. It's a way of evaluating competitors, potential acquisitions, potential partners. It says a lot about a firm, about their technology, their focus on consumer experience, and again, kind of their willingness and ability to engage in that. And finally, we have a real need, as Will described, to be able to make sense of the data, to be able to perform analysis over it in a reasonable way. And those are going to cover a few different dimensions, one of which is the ability to really automate reports, have some analyses that roll up on defined intervals and defined ways, to be able to integrate both the reports and the raw data into a production setting as needed, as well as perform ad hoc analysis. And so as we look at all this, this question of, does the cloud serve us best? How do we make this decision? And that was one of the conversations we had with Will and the Kantar team very early on. And already, right off the bat, when you're working with ad data, there was a real gain from moving into the cloud, which was this notion of regionality. So we've talked about the need to have low response times. And here we're looking at a map. You can imagine if we're asking our customers over on the East Coast to ask for responses from a server on the West Coast, there's a delay to that. There's a certain latency and extension of the response time. But once you go global, you really feel it. So when you're asking people in China to ping over servers all the way in the States, you're introducing real latency, real response time delays that are just unacceptable. And so the solution in the online advertising space, be it video or otherwise, is to have local servers, to have edge nodes distributed globally that solve this problem, allow people to be geographically closer to the server their computer is speaking to. Now, there are a number of ways of doing that. We can, invest upfront in kind of co-locating servers and things like that. Will's going to talk more about the balance between investing upfront and what you can do in the cloud. I'll simply hit it at the ability to have global presence upfront over AWS was a huge win and a key reason to keep driving forward over that platform. Another reality, I'd mentioned this earlier, that there's an interplay between current organizational state and systems architecture designing systems is not just about having a system that works, it's about having a system that you can maintain given your current configurations and your current organizational skills. So one of the things we talked about was that in particular, AWS as a cloud service, the Amazon Web Services as a cloud service, allowed us to have services in the cloud, not just hardware, not just operating systems, but as we'll see in a moment, kind of deeper, more robust services that will allow us to work with our data without having to worry about how they work underneath, whether we're talking about NoSQL solutions, whether we're talking about distributed queuing just as a service with a RESTful API embedded into the system, knowing that we don't have to take that DevOps ownership and worry about, well, who is my systems administrator? Are they familiar with these technologies? How long will it take them to get ramped up and prepared to support my system, be ready to expand my system? Those are all challenges that start to melt away as we move into the cloud. So to that end, won't be surprised to find out that there are equivalent architectures in the cloud. So we can think of a number of ways of doing this solution, of driving this forward successfully, that have just trade-offs in terms of their organizational impact, in terms of the complexity, in terms of the time to solution, in terms of their overall cost to maintain. And so what we did with...
I'm so proud of the Lightboard, by the way, Dan. Thank you.
This is our deepest technology right here, right, Will?
Yeah. Cutting edge, that's what we use.
Oh, yeah. So this is actually a live shot, if anyone can't tell, from our phones on the whiteboard. So we sat around with Kantar. We spent a few days on site really ideating and then architecting potential analogous systems. And what you can see here are 4 equivalent systems we were kicking around. So the first one really leverages Dynamo as a NoSQL store as a way to store intermediate data quickly as beacons queue in and then get pushed into either S3 or kind of directly doing big data Hadoop jobs over Dynamo, which is a real possibility. The cost was high, and the need for real-time data, which is where NoSQL stores like Dynamo really shine, was just not there. So we really focused on the 2 architectures below that. So you'll see the middle architecture there is effectively a queuing system. So data comes in, it gets queued very quickly for fast response, and in the background you have workers that'll push the data to S3. Now a similar solution to that is to use Flume. That's what you see at the bottom there. So Flume, for those of you who are unaware, is a common big data tool for ingesting data at scale, and it effectively builds up a hierarchy of machines, all of whom talk to one another, kind of further aggregating data each step of the way until it's able to kind of push down very, very large chunks of data in efficient ways into things like Hadoop, or in this case, S3. The flip side of that is that these architectures, again, require a series of machines to set them up, and Flume is not provided as a service from most cloud providers, so there's DevOps overhead. And so we ended up deciding, kind of based off the Kantar organizational configuration, their need to be able to move quickly without having large amounts of retraining and reestablishing folks' time, particularly around systems administration. There we go, sorry. Was to go with this final configuration. And so what you see here is a robust solution for very quickly ingesting beacon data. Over here on the left, data comes in through a load balancer. It hits a series of edge nodes which exist within regions. So in AWS, we have both regions, and within those regions, we have zones. And so what we're always going to do is ensure we have multiple zones in each region. And for those of you who have maybe heard the Netflix story, there are scenarios where zones can go out, but regions themselves will stay up. Always one zone will be available. So as long as you duplicate your data across zones, you have 100% availability. It's a great DR solution configuration. So it's exactly what we did here. The data pushes through from the edge nodes into the queue and immediately returns a response. In the background, we have worker nodes that are dequeuing the data and pushing it into S3, into log files. And then finally, we have an elastic MapReduce, a Hadoop cluster over S3 that's working on generating reports. And the exciting thing about architectures like this is just how easy they are to scale. So if you look at the solution, the queuing, the storage in S3, the elastic MapReduce, all of these things, everything that's been grayed out scales effectively for free. And all Kantar has to worry about is when the rates go up too high, if they feel the system's under strain, they can add new edge nodes, they can add new workers, they can horizontally scale the system with a push of a button. And that's one of the key stories about big data. It's about introducing these kinds of systems where we can horizontally scale. And when we do it in the clouds, you can see we can greatly reduce our complexity and the total amount of oversight a system needs in order to be successful and have high uptime. So a final story about working on the cloud that I think is a very important one. A lot of folks, if you look here, we have two architectures. We have effectively how AWS works. It's compute clusters over centralized data in S3. And on the other side, we have on-site clusters, right? So many of you have probably worked with these. I've got hard machines that have both storage and compute and memory all in them. They're all configured into just a standard typical physical cluster. And when folks talk about the advantage of being in the cloud, there's a lot of discussion of, well, things like Elastic MapReduce handle some of the nastier services like my name node and my job tracker and some of the stickier points of Hadoop. But it's also the case that it's very easy to add new data nodes. So it's easy to add new compute power. It's also easy to add new space. And those are great advantages of the cloud. I would never undercut those. But there's a deeper point that's really important to appreciate. When we work in analytics, there's a need to be able to ad hoc query the data, to be able to touch the data, to be able to make sense of it, to find new insights, to pull and play with the data and see what it's telling us that's not already part of our existing systems, our existing production systems. And when we do that, sampling the data often isn't enough. So the notion of having kind of a small research cluster doesn't quite work because there's often signal that exists between data sets, between points, where you have to have all of it in whole in order to have the accuracy and the insights you really need. So at that point, there becomes a challenge that many organizations face, which is, well, running ad hoc queries over production is fundamentally dangerous, right? One bad script brings down production. And in fact, we've seen that. I've been in situations where guys had a missing shebang line on a pig script. For anyone who's more technical, effectively, it tells the computer how to execute a program. And because that was missing, some syntax in a Hadoop file looked like it was a bash file, and they effectively inadvertently created a fork bomb. It was a typo in a file that caused them to bring down an entire production cluster. That's never a scenario you want to be. That's dollars lost, and it's a lot of hassle and a lot of concern for everyone in the organization. So do you pull aside a separate research cluster? Absolutely. But if you have to, as we see in the on-site, recreate all of the data, now you've got data mirroring challenges, which are fundamentally complex and they're also extremely expensive. And this is one of the really interesting things about building Hadoop clusters over S3 is you can have separate compute over the same storage. So you can store all of your data once in S3, take advantage of the natural replication within S3, and then just spin up multiple compute clusters that all point to the same location, the same storage location on S3, in order to allow you to have a production cluster right next to your research cluster with fully mirrored data for free. And that's a really exciting and very cool capability of working with analytics in the cloud that helps people drive new innovations. And with that, I'm going to hand this back to Will to kind of talk more about the future and what they've been doing with the system.
Yeah, thanks, Ben. That is one of the neatest things. Just to echo that, we've already gained a whole bunch of capability with being able to give my data scientist access to a node and let him go and explore some of the early findings in the data without actually having a risk that our production jobs are going to be impacted by it. I think it's one of the greatest advantages. We love it. So when we're talking about from a business standpoint, from a business benefit standpoint, from a technology technology benefiting the business, I chose this photograph because I think it really illustrates at least that traditional way of thinking of how you had to scale your capacity. and you had to overscale. You had to buy more than you need. That step function here, it's that graph there with the shadow shows that you would have to over-purchase capacity and then maintain and hope that your revenue would meet that capacity over time. One of the really nicest things that we have, at least, is we have a platform now that we're able to add as many different partners on there as we'd like to do this sort of thing, and I can scale my capacity with revenue as opposed to scaling and hoping for revenue. That's really a wonderful a tool in your arsenal, I think. Now, the other big benefit is the way that we designed the architecture. We don't have to actually use we don't have to use it for exactly the way it's constructed, or just for web video commercial beaconing. This actually gives us the capability to do direct measurement in almost any form. With us being able to silo the data using allowing Hadoop to act upon the natural partitioning that occurs on disk, we can use the same infrastructure to do direct measurement on a web page if we wanted to, or a specific campaign or survey with some of our internal partners. It allows us to expand in ways that we don't even know that we're doing today. It allows us to go ahead and grow in many different future uses without having to scrap what we have and rebuild. But I think really the biggest benefit to us, if you really think through it, is the unlimited potential that we have in the data we're tracking, in the way that we're storing it, and the way that we're analyzing it, that we haven't unlocked yet. If you do a traditional data gathering approach, you one of the biggest things you have, if you're old school ivory tower data guy, it's I need to figure out what I'm going to be using this data for, therefore I can store it in a certain way. In using this technology and this approach, my data team can explore the data and find new insights that we haven't even dreamt of yet. And that's what I think is one of the biggest benefit of all. There's no barrier at all to ad hoc querying. There's no barrier at all to truly playing with the data and delivering or generating new potential innovations and insights. And I think that's all I have in here. Dan, that's all I had to talk about.
Fantastic. And so I will echo, not just the ability to perform ad hoc queries, but, as part of that, kind of one of those stories of big data that always comes up, and it's certainly worth mentioning in the context of online advertising as well, is storing all of the data in an unstructured form kind of takes away that problem of, well, which fields do I keep when I'm ingesting it into my RDBMS, right? So that's a really common issue when we talk about, performing ETL or performing data ingestion in organizations. Is back in the days of, traditional RDMS warehouses, we always say, okay, well, I need to structure this data to fit into the columns. I have a limited amount of space. You tell me which fields you absolutely need. Instead, the story with big data, and particularly technologies like Hadoop, is we call them read-time schemas. So you store all of the data, and then at that point you're reading the data, then you can apply a schema to it. At the time you're reading it, you can say, oh, well, I care about X, Y, and Z fields, and this is how I want them structured. And when we talk about supporting ad hoc analytics, being able to ask questions we never even thought about asking before, like Will was describing, that's a really important supporting technological aspect of the system. So with that said, we're going to call a few of the questions. A nice simple one. Someone had asked what the name of the tool I was mentioning was. It's Flume, I believe. Thought it sounded like Fuma, so I'm assuming you're talking about Flume. So Flume is a data ingestion tool. It's Flume, and it's also bundled within the Cloudera package, which there's another question about what is the difference between Cloudera and AWS. And so at a high level, both use the Apache open source. And so effectively what's happening is they are very similar, except AWS is taking that Apache source, putting it into their cloud, allowing you to scale it as you please, spin it up, spin it down as you please. If you only want to cluster up for 1 hour out of the day to run a big analytics system and then pull it down, you can. Cloudera is designed for on-premise. So it's an support solution over the open source tools. to allow you to run on-premise. And then they also provide some very nice dashboards and other tools for maintaining the healthier cluster. And for those of you who are looking and playing with Hadoop, I think you can get your first micro instance up on the cloud with AWS. They might even have a free option of that, if I remember correctly. And certainly, if you need a local one, the Cloudera tools are a little bit easier to set up. I keep that installed on my Mac at all times. So there's a trade-off there in terms of, hey, do you need something to play with locally? Or are you looking for a solution where, as Will says, it's one of my favorite lines, you can scale with revenue instead of hoping for revenue, which obviously is a great aspect of AWS. So with that said, another person asked how long it took to get the system up and running. We had this, I guess it was about 3 weeks in execution time. Is that right?
Yeah, that's right. Actually, from the first day we got together and said, here's what we're thinking about doing, 3 weeks later, you delivered the run book. So, yeah.
We do our best.
Yeah, it was pretty amazing, pretty astounding. We did this just as a follow-up. This was not just a requirements gathering, go build something off-site, and then come back and deliver. I know I mentioned it was a little more than that, but to some more detail, we did requirements collaboration, and then during the build process, we did code reviews, all via online WebEx with you guys, so that our folks were actually involved in the process all the way through it too. It was pretty nice. When we did the turnover, it wasn't blind.
Yeah, and Kantar is a great team to work with. For those of you who are over there in Pennsylvania, I would highly recommend the application. But it's a great way to learn these tools, is to do them side by side. It's really where the value is in taking the velocity of bringing in third-party consultants like Think Big, and not just staying on the outside, but coming together and really having day-to-day interactions, touch points, and doing knowledge transfer of both kind of explicit skills as well as the tacit knowledge that comes up in these little bugs or little day-to-day analytics questions, really doing those together and making sure that knowledge transfer takes place. And it leads to another great question someone has here. So with all of that tremendous knowledge transfer that happened as part of this project, what's the real value of this data? What is Kantar Media Intelligence doing with this today?
Oh, right. So it fits into our entire platform, our customer-facing platform. Since we're an entirely independent organization that monitors advertising activity, we have a whole bunch of front-end products that customers buy, and they can get access to advertising data. With the video metrics, it's we brand everything down to a multi-million product database that we have across all 26 media. So we can answer the kind of question like, what is Pepsi doing on the West Coast to reach a certain demographic in magazines and online video? So we gather everything at the most granular level, and we roll it all up so that you can ask those kind of macro questions with all the underlying data. So this is what the value here is, that we're getting census level data for this one partner that allows us even deeper and more specific answers.
Fantastic. So with that, I believe we've reached all but our last question, and I won't say where this question came from, but folks are very curious to know, Will, where can we see you next?
I'm not sure. I'm appearing all over the place. I'm sure it'll just follow me on Twitter, and I'm sure I'll cover that. Thank you, Dan.
Fantastic. Well, thank you, folks, for joining our webinar. If you have any questions, Will and I's information is up on the screen here. Feel free to email us, ping us, certainly engage the Think Big website for additional webinars and insights around big data and R and data science. More and more will be coming your way in the next month or two. So thank you, guys, and have a wonderful afternoon.